Say take.
Take three.
Hey Robert, I just got a call from a contractor that said he has cast several anchor bolts with inadequate anchor bolt projections. What do you typically do for anchor bolts that are too short, and what defines short anchor bolts?
AISC Steel Design Guide 1, Base Plate and Anchor Rod Design, is the authority and first place to go concerning anchor bolts that are in the wrong place, bent, or short. There is an entire section discussing anchor rod repairs. The first question to answer is to determine if the anchor bolt is indeed too short. I hear many engineers state that the threads of the bolt extend beyond the top of the nut by 1.5 threads. This is not an AISC requirement. AISC Steel Construction Manual Part 7, Design Considerations for Bolts, states that bolts are considered to develop adequate thread engagement when the end of the bolt is at least flush with or projects beyond the face of the nut. If your anchor bolt does not extend flush with the top of the nut, then Design Guide states that, quote, a conservative estimate of the resulting nut strength can be made based on the percentage of threads engaged, as long as at least half of the threads in the nut are engaged, end quote. From this it can be concluded that yes, you may have short bolts, but there's still capacity in the connection as long as half the threads are engaged in the nut. What type of loading are the columns being subjected to? Moment, shear, tension, compression? What do you have?
Well, for the first case, let's just consider just a gravity column that is not part of the lateral system. And it does not have any uplift resulting from the components and cladding loads either.
Well, great. That's a easy question to answer. In this case, I consider the bolts only being there as an aid to erection. As such, the bolts are not subject to tension in the final configuration of the building. Also, the contractor, as should be specified on your drawings, is responsible for means and methods and is responsible for temporary shoring of the building. That being said, I would not require the contractor to do anything to the bolt if at least half the nut is engaged by the bolt. If the bolt is shorter than this, then the quickest option is to drill a new hole in the base plate and install an epoxy anchor.
Robert, that sounds like a lot of trouble. I specified an anchor bolt that was weldable. Can't I just plug weld the top of the nut to the bolt or put a fillet weld around it?
Many engineers in the past have allowed welding to the nut to the bolt. This is not a repair fix identified in the manual of practice or the design guide. Obvious reasons why they include subject the nut to extreme temperatures, bond of the weld to the rod, and lack of any examination procedure to determine the effectiveness of the weld. Some engineers in the past have also allowed welding to the bolt to the base plate. To do this, the column would have to be taken down after determining the anchor was short. Then the anchor rod hole in the plate prepared with a bevel, then the column placed back in position. It would likely be more cost and time effective to simply drill a new hole and place an epoxy bolt.
So suppose that my anchor rod was a 1-inch diameter ASTM F1554 grade 36 weldable anchor with heavy hex nut with a maximum unfactored tension load of 14 kips. The special inspector for the project indicated that the bolt is a 1/4 inch short of being flush with the top of the nut.
This is an easy check, Greg. Table 3.1 in the design guide shows capacity of the bolt as 17.1 kips. The nut is 1 inch tall, and you are a quarter of an inch short from the top of the nut. Thus, your bolt is engaging at least half, so you can approximate the capacity of the connection per the design guide. The bolt is engaging the nut 75% of its height. You can approximate a conservative estimate of the connection as 75% of 17.1 kips, which in this case is 12.8 kips. This is short of the required 14 kips and thus will have to be further investigated.
What's my options for those further investigations?
Options include adding an epoxy bolt, welding an extension on the bolt, or extending the bolt using a nut coupler. I personally do not like adding an epoxy bolt because the possible differences in developing an epoxy bolt in concrete versus developing a cast-in-place bolt If this was a gravity column, no problem, but this is a column with tension in the anchor bolts. It is okay to weld a bolt to the existing bolt. This requires a lot of prep work by a certified welder. The design guide discusses this. As previously stated, it is not okay to weld the nut to the bolt. Welding the bolt to the column base plate is an option, but again, you need to carefully consider development of the group of bolts using both bolts and welding. Welding would not be my first choice. I prefer the use of a nut coupler, as described in the design guide. Details are shown in the design guide, and the erector can order what he needs from the fab shop, modify the hole in the base plate, and have the column erected with full capacity of your bolts.
Any other suggestions?
The ASCII design guides are a great resource in your office to have available for your engineers. If you do not have them, I would encourage to obtain the whole set. Design Guide 1 also discusses bent anchor rods, bolt arrangements. They may have been rotated 90 degrees from correct orientation.
Hey Robert, I do appreciate your help very much, especially reading my incorrect notes on this piece of paper. So thanks a bunch, and we'll talk to you later.